Hello, everyone. Thanks for joining me for my talk today. So my name is Juntao from Cornell University. So today I'm going to talk about the unrestricted split-antecedent Anaphora resolution. So this work is in collaboration with Nafis, Silvio, and Massimo. So let's first take a look what is a split-antecedent Anaphora. So for the plural mentions, so they can be either resolved with a single antecedent, such as the example 1 and 2. The Johns went to the park, they had a good time, or the John and Mary went to the park, they had a good time. So in both cases, the antecedent of the anaphora they is one single mention. So this is counted as a single antecedent plurals. But some of the cases is more complicated, which become a split antecedent anaphoras. So such as the example here, John met Mary in the park, they had a good time. So we have the two different antecedents for they, one is John and one is Mary. Or if the case is John likes green or Mary likes blue, but Tom likes both colors. So the both colors refers to green and blue. And all the previous works on the reference resolution is mainly focused only on the single antecedent anaphoras, but without the touch of split antecedent. So this work is first work on the unrestricted split antecedent anaphora resolution. And so let's take a look. So the main challenges for the split antecedent anaphoras is because of the not enough resource for training good enough systems. So the largest corpus we find, with unrestricted split antecedent anaphora annotated is called the raw corpus. And in total, we found like 700 split antecedent anaphoras, which only we use 500 for the training, so which is very limited. And in order to boost the performance, we in this paper we investigated like the 4 different auxiliary corpus. So the first 2 corpus are annotated with the split antecedent anaphoras, but it's crowdly annotated. So we are using this from free detective games. And the third and the fourth corpus is from the annotated in the ARAL corpus, which is a bridging reference and also single antecedent anaphoras. So I will talk this into the more details. So the free detective corpus is collected using the free detective games, where the users come to play the game and then annotates the coreference for us for both single antecedent and the split antecedent cases. So the corpus can be downloaded freely from our GitHub page. So in order to use the corpus as a normal corpus, we have developed a mention pair and annotation module aggregating method, which is able to deliver a high quality labels from the crowd annotating, from the noise annotations. So in which, if we use the silver labels, we can find in total 500 split antecedent anaphoras. And this is a recall of around 70% of the gold split antecedent anaphora if we evaluate it on a small goldly annotated portions of the PD corpus. But there are more, the split antecedent annotations from the crowd annotations. So that's why we introduce all the second corpus using the crowd annotations, in which we found in total around 70K split antecedent anaphora annotations associated with 6K mentions. So which means we have around 6K split antecedent anaphora detected using the crowd annotations. And this recalls around more than 90% of the gold split antecedent anaphoras if we use our predictions against the gold portions of the PD corpus. And this also includes a large false positive as well, but we find that the vast majority of the false positive cases are due to the 2 different misunderstandings. Some of the users annotated the reference chains as a split-antecedent anaphora, and some of the users annotated in addition the bridging reference, which is not required for the annotation of the corpus. But those two types of the errors did not affect our performance, as we were using the similar source as our third and fourth auxiliary corpus. So the third auxiliary corpus is we're using the element of bridging reference, which is annotated in the raw corpus. And so the reason we use this is because the plural mentions, the relationships between the plural mentions and the individual antecedent, antecedent of the mentions is actually an element of inverse relationship. So if we use the element of bridging reference and or the element of inverse bridging reference, it's very similar to the plural split-antecedent anaphora cases. So in total, we found 1,000 examples for our third corpus. And for the fourth auxiliary corpora, what we use is called the single reference, which is a single antecedent anaphora cases. And we have way more examples for these types of the reference, which we found more than 30K examples here. So, and in addition to the 4 different corpus, we also evaluated 3 different training strategies. So our system is based on simplified versions of the Leotard 2018 and using the BERT instead of the Elman embeddings. And we have the main training corpus using the split-antecedent anaphora and the auxiliary corpus, like I introduced before, the 4 different auxiliary corpus. And we trained with 3 different strategies. The basic strategy is called the concatenation. So basically, we concatenate the 2 training corpus, and 50% of the time, the system is trained on the main corpus, and another 50% of the time is trained on the auxiliary corpus. And the second training strategy is called the pre-training, where we train the system first on the auxiliary corpus and then on the main corpus. And the third strategy is called the corpus anino, so which is a soft versions of the pre-training. So basically, we first train the on the auxiliary corpus 100%, and then linearly decrease the use of the auxiliary corpus and increase the use of the main corpus. And in the end of the training, we will have 100% trained on the main corpus. So for evaluation metrics, we report 2 different metrics. One follows the Valata, the lenient scores, and also we reported in additional the strict scores. So the lenient scores gives a partial credit if a mention is not resolved purely correctly, but partially correctly. So take a look at the example here. So if the antecedent for all 3 colors is green, blue, and black, and the predictions only gives us green and blue, according to the linear score, it will have 2/3 of the recall and 100% precision, which gives us a F1 score of 80%. And for the strict evaluation, we will have a 0 score here because it's not fully correct. We only give it a credit if the prediction is green, blue, and black. So the first things we do is we're trying to select the best training strategies for the different auxiliary corpus. We did this on the development set. As we can see, the baseline system that trained only on the main corpus is already give a reasonably good linear score, which is 58.2. And if we use any of the auxiliary corpus, we will be able to boost the performance by more than 11 percentage points, which is using the single reference auxiliary corpus. And we also figured out the best training strategies for the PD Silver is simple concatenation, and for the PD Crowd and element of is using the pre-training, and for the single reference is using the anino method. So after that, we applied to the test set. So in additional for our neural baselines, we also introduce some naive baselines to show that how hard the split antecedent anaphora is. So the first few is the recent 2, recent 3, 4, 5 is a method we simply use most recent mentions as a split antecedent up to 5, up to a certain number of the mentions. As we can say, it does achieve some lenient F1 scores, but in terms of the strict accuracies, it's nearly 0. And also, if we use a random selections, it also gives a very poor score as well. So our neural baseline achieved a relatively good result already, 58.6, and for the strict accuracy, it has a 22 percentage point. And if we use our any of our auxiliary coppers, we can largely improve the both lenient score and the strict accuracies. So for lenient score, we can achieve 11 percentage point improvement, and for strict accuracies, we achieved even more improvement, which is 20 percentage point. And we also evaluated trying to combine the different coppers to say if we can push further the performance. And the best result is achieved by using the PD crowd and elements of and the single antecedent coreference together. So it's just slightly above the performance if we use a single coreference alone. And we also did some analysis on the result. So the first things we did is we trying to say if the number of antecedent matters for the for our system. As we can see here, the baseline system works quite good, and the two split antecedent anaphoras. But with if the mentions has 3 or more antecedent, then the performance drops dramatically. While our best system achieved quite similar lenient scores for both cases, but for the strict evaluations, the performance drops drops like 20 percentage point, but still much better than the neural baselines. And another evaluation we did is we trying to say about the different size of the coppers matters for the performance. Because a single antecedent coreference is much larger than any other coppers we have, so we evaluated on the conditions if we only have like 1K examples, which is equivalent to the bridging reference, and where the system achieved a much lower result, which both lenient scores, the lenient scores when compared to the bridging reference. So it's also so that shows that if we have the similar size of the training data, then the bridging reference works better than the single coreference because it's more closer. And if we have the 6K cases, which is similar to our PD crowd examples, and the system achieved a very similar result than the PD crowd. And if we further include more examples, the performance improves further. We also did some give some examples from the system predictions from our best and the baseline system. As we can see, our best system have more green part, which means like the true positive, and both the false negative and the false positive has been reduced in all the examples here. And if you are interested in our system, both the pre-trained modules and the code is available in my GitHub page. And thanks for listening.